Geometry for high school, conic section that includes circle, ellipse, parabola, hyperbola. Why these shapes, geometries are called conic section? Conic is the cone, inverted cone you have. You take this cone and take the cross section. This is cross section. Okay. If you slice it horizontally, you get circle. You tilt slightly, you get ellipse. You tilt it further, then you get parabola. This is nothing but a quadratic shape, quadratic equation. Then if you really tilt it to vertical position, then you get the function on the both side, right? It's called hyperbola. So depend on the angle of the slicing conic, the section, cross section, the shape become 4 different shapes, but they are originated from the same inverted cone. So why these shapes are important? The orbit of a planet, moon and satellite, they are going around. Actually, most of the time it's not circle, it's ellipse. Sometimes very, very skewed ellipse. Okay? And within the ellipse, any light or wave that start at the one focal reach to the another focal. So suppose you have ellipse, not like a circle, you have a 2 center, and if you shoot the lights here, then it's reflected back and hit another. There are 2 forces. So one focus point and another focus point has a relationship. Any light shot from one side is going to hit another side. Okay, this principle is used in lithotripsy, a medical procedure for treating kidney stone. When a patient sits in an elliptical tank of water, high energy shock wave generated at the one focus that will be propagated to another focus where the kidney stone is. So here's a kidney stone, and patient is lying in the water bathtub, and we issue the ultrasonic sound in the water. This is water. Then it's all bounced back. The wall of the bathtub, it's the ultrasonic sound bounce back and hit this another focus point. Okay, so you can target ultrasonic sound to the focus point, which is a kidney stone. Okay, that's a kind of application. The parabolic antenna is used to collect the radio wave. So parabolic antenna is used to collect the signal. Okay, the hyperbola revolving around its axis form a surface called a hyperboloid. This type of geometry is used to diffuse heat from the hot spot to outside. So hyperbola diffuse the heat. So any heat comes in, it's diffused. And also the light comes in, bounce back, and hit this focus point. If it's a parallel means the light far away from the galaxy. So those are optical telescope use hyperbola shape. So there are many applications for those. That's good to know, right? Before you learn. Okay, now very general form of conic section function is ax squared plus by squared plus cxy plus dx plus ey plus f. The constant f equals 0. So it's like you used to have a x squared plus b x plus c equals 0, right? Then you flip x and y and combine them together, kind of function. Okay? And now generic equation may give you ellipses like this one. Okay? Ellipsis is not elongated along x or y, some kind of angle, and the center is off from the coordinate. So if you set a new coordinate here, okay, it's not enough. Now we have to set tilted coordinate. Here you go. Tilted coordinate. Then it look like on the tilted coordinate ellipse look like this symmetric. Okay, then you get this kind of formula, ellipse formula, square a square plus minus, this is not ellipse, this is generalized form. Ellipse, if it's centered here, it's going to be y square over a square plus y square over b square equals 1 and plus, right? Right? So we can simplify the equation to this form, the familiar form you learned so far in the middle school or algebra 2. In order to do that, we have to do several things. The first, xy has to be shifted. The function has to be shifted. So shift 1, shift 2, you enter this. This is a new coordinate, right? And move to the center. Then how about tilting? How do you correct this tilting? You select carefully the coordinate with some angle. That called coordinate rotation. So in this case, it's not going to be x equals y equal this shape. It's going to be the new coordinate is going to be there's a cosine theta, sine theta in this matrix. This is coordinate rotation matrix, and that's I show you later. The new coordinate depend on the old coordinate xy both, and new coordinate y prime depend on both x and y, and the angle theta. And why this is good about, once you do that and eliminate this term cxy, interactive term, okay, so how do you eliminate? you substitute this equation, and any cy, the cxy, this coefficient is set to 0, and that's the value you choose. You get that? This is algebra issue. So after you plug in this one, collect xy term, and this term is set to 0, find a condition of theta that gives this 0, then xy term disappear. Okay, so that's a new coordinate. The new coordinate doesn't have xy term, so it's become only x and y. And if you convert the coordinate to the parallel position, then it's become simple: x square, a square. Hyperbola is negative, ellipses positive, like this form. You get that? So after eliminating the tilting, it becomes like this, and plus minus. If minus, it's look like hyperbola is like that. It's tilted, the theta. Okay, and after you collect this, the new look will be like this. Okay, so coordinate conversion, coordinate rotation, and coordinate movement in parallel position to simplify the conic function equation. And the first one you see is the circle. The circle is when A equals B here, right? And of course this plus ellipse. Now then it's a circle, and the circle position is shifted by x1, x2. This is a shifted function. Okay, so the circle is sitting here, and the center point is x1, y1. It's shifted. Okay, if you change the coordinate, then it's centered at the origin. So since A equals B, this is going to be the circle's equation. Okay, so if you center by moving the coordinate, then it's simplified down to this familiar equation: x squared plus y squared equals a squared. So this is the essence of the circle, and the remaining is like the coordinate. In the circle, good things about circle is you don't have to worry about xy term. This term is doesn't matter because it's symmetric. It's tilting or not, who cares, right? Okay, so let's look at the ellipse. This is extremely important function, and it's studied a lot by Galileo and Kepler, and finally Newton's explained why planets move along the ellipse orbit. Well, the key was the gravity force is inversely proportional to the square of distance. And with this rule, the Newton figured out the planet can go around the sun in the orbit, the ellipse orbit. Okay, so that's what the significance is. Without this gravity rule, gravity, it's not gonna be ellipses. So gravity is the cause of the planet orbit going around ellipse. Okay, so this is very deeply related, gravity rules and orbit shape. Now if you shift the coordinate again, it's settled at the origin, then ellipse equation becomes simple, and this length is A, this length is B. Okay, conic function hyperbola. We skip parabola because it's basically y equals ax squared plus bx plus c, quadratic equation, and we did that practice a lot in algebra, so we skip that function. Hyperbola still has the x and y term, it's just negative here. Okay, and if you move to the origin as a center, then it's becomes simple equation like this, and it's look like this. Okay, conic function hyperbola. Okay, there are many characteristic of those functions, and that's a part of a high school geometry, and you do this in the algebra 2 area. The same thing. This conic section is kind of overlapping subject between geometry and algebra 2. Okay, so it said a plus b, a square plus b square is c square. The distance d1 and d2, difference of the distance. So hyperbola, you can define a, its intercept, and the b. How do you determine the b? The focus point, you draw the line up, and this asymptote line, the height is b. Okay, so a square and b square equals c square. The difference between d1, d2, any point on the hyperbola, you measure the distance to two focus point, d1, d2, is constant. And the proof is here. Yes, you can stop the video and go through these similar things. You can tell. This 4c coordinate is given. Figure out the equation, kind of. You can practice this. Similar claim you can make for the ellipses. You take A, B, and C. This is negative C, right? Yeah. And distance, any point on the ellipses, you measure the distance, then d1 plus d2 equals constant. This time is plus. Hyperbola, this is negative. And there are many theory about the focus point, and because to make a telescope, focus point is very important, right? So how do you set the focus point correctly? In order to figure out that, there are many theories developed for this. And if you are going to work on a telescope or lens in the future, you have to study this more. what the role of the focus point in this shape, because telescope and antenna use those. Okay, so any engineer or scientist has to know about this. Okay, I hope you enjoyed this video, and I'll see you in the next video.